Hello, everybody. Got cut off. So there's our line. Let's do the last page here. This next one shouldn't take us too long. It says write an equation in general form for each line described. So we got a vertical line passes through the point -1, 5. So let's locate -1, 5. So -1, 1, 2, 3, 4, 5 right here. And it's a vertical line, so looks like this. And what's a line to describe this? I would say that, we only have an x value. It looks like x equals -1. So this is all the information that we have. There's no restrictions on our y value. This line exists at all possible points of y. It exists at every single point, spot. There's no restrictions on it. And then let's just remember our what we need to satisfy in order for this to be in general form. So we actually don't need to have everything. You don't need to have both like the AX and the BY. So since there's no restrictions on Y, we don't need to show it. But we do still need to have everything on one side of our equation. So let's move the 1 over by adding 1 to each side. And so we've got an x plus 1 equals 0. And then you can see that this is true, that -1 plus 1 does equal 0 at every single point. So there you have it. Let's do our next one. We have a horizontal line that passes through the point -4, 2. So we'll keep it 1, 2, 3, -4. And then, what am I doing? Negative, we got to do x first, -4 this way, 1, 2, 3, 4, and then 2 right here. Wow. And it's a horizontal line, so going like this. And so now we have no restrictions on our x's. It's only where y equals 2. So, y equals +2. It's a horizontal line. There's no restrictions on our x's. It exists at, 0 and 1 and 2 and 3 and 4. But we can't have, we need to have everything on one side. So let's -2 from each side. And we are left with y minus 2 equals 0. Okay. Next ones. These ones, it's just kind of a substitution question. So it can seem a little bit intimidating in the beginning, but just substitute the information that we have to find out what we don't know. I actually might just do one of them, and then I'll do that question from before. So I might just kind of get rid of this one down here, and then I'll substitute that one from before that I said I'd try to get back to. So let's do that. So 6x subtract by plus 1 equals 0 for the line that passes through the point -1, 5. So determine the missing value of a, b, or c for the following linear relations. So we have a missing value of b. We know our a, we know our c, but we don't know this b. We do know they gave us right here the value of x and the value of y. So we can input that information into our equation. So 6 times x, which is -1, subtract b, which we don't know, but b is being multiplied by 5, plus 1 equals 0. So let's figure that out. 6 times -1, -6, subtract, 5b plus 1 equals 0. We can now, combine our like terms. We've got a -6 and a +1. So that's going to be 5. I'll keep on writing it. Why not? So we have now -5 subtract 5b equals 0. I would like our b to be positive. So let's add 5. I'm going to do a different color. Let's add 5b to each side. And we get negative 5 equals 5b. And now our last step, to get the b by itself, let's divide by 5 on each side. And we're left with b. This becomes 1. So b equals negative 5 divided by 5 is a negative 1. So there you go. That's the missing value of b. So if you need to do it for, A or C, it's kind of the same method. That's the one that I deleted. It was just the A. So you're still just replacing the X and the Y using the information we know and then solving for the A instead. Same kind of idea if we were solving for the C, input the information we know into the X and the Y and solve that way. And the one that I said that I was going to solve up there, why it's kind of tricky. How did it go? Y equals 0.4x subtract 0.4. So this is a bit of a throwback to what we were doing before. Y equals 0.4x subtract 0.15. And these ones were just converting this to general form. And so we want to get rid of these fractions or these decimals. I think maybe the easiest way to do it is to think, okay, what can I multiply 4 by and 15 by to make them whole numbers? And to move this decimal place over once, we could multiply it by 10. So this, as a fraction could be 4 over 10. But as a fraction, it could also be 2 over 5. This one if we want to move the decimal over, we have to multiply it by 100. So we could have it as, maybe I'll write some of this down. You could do it as 15 over 100, or you could think about that as, if we divide by 5, 3 over 20. This one we could do as 4 over 10 or 2 over 5. And when you're thinking about them in fraction form, then it's a little bit easier to think about a lowest common multiple. But I think it might be easiest just to multiply each by 100. And then there's a kind of final step that you need to do with these. So if we times this by 100, and we also times this y by 100, we're going to get rid of our decimals. So you end up with 100y equals 0.4 times 100 is going to be 40x. Subtract 0.15 times 100 is 15. We want, remember, a positive x, so let's move this y over. Let's subtract 100y from each side. Now we have 0 equals 40x. Subtract, I missed a 0. Subtract 100y, subtract 15. And now here's the kind of, last part. This seems like a good answer, and I would say that it is, but we can also kind of factor out, think about our polynomials, a common factor. And so, 5 can go into each of these. So it is good to, divide this side. You can think about dividing this side by 5 as well. And I think that's the kind of best way that they want the answer is to be in its lowest form. So we'd still have 0 equals 40 divided by 5 is 8x. Negative 100 divided by 5 is negative 20y. And negative 15 divided by 5 is negative 3. So, from the beginning, we could have multiplied each side by 20. That would have given us here 8 and would have given us 20 here or 20 here and 3 here. But it's kind of hard to see it, and I would maybe start by just making them all into whole numbers, and then if you can at the end, factoring something out. Okay, thank you so much. I'll let you know what textbook questions I'd like you to do.